Um, Next, I'd like to introduce Brandon Krumwiede. He is the Great Lakes Geospatial Coordinator for NOAA's Office of Coastal Management, which is part of the National Ocean Service, where he uses remote sensing technologies and data analysis to study coastal systems, geomorphology, and human vulnerability to coastal hazards. In addition to serving as a co-PI on one of the current GLRI-funded studies for the Illinois Beach State Park that we heard about earlier, Brandon's also involved in product development for tools like NOAA's Lake Level Viewer. Brandon, take it away.
All right. Thank you so much, Chiara. Appreciate the warm introduction. So I'm going to build off of Lauren's presentation. Lauren did a really good job of explaining the water levels, and so I'm not going to touch on that quite as extensively as what Lauren provided, but more focused on the direct coastal impacts that we're seeing due to these changes in water levels. So next slide, please. As you all are probably aware, the one thing that a lot of people ask, what do you do for your job? And I say I work in the coast. They're like, well, why? I think it's because of this in particular piece. It is a challenge working in the coastal areas. Naturally, the shorelines are very much dynamic. They're complex due to the fact that, going back to Lauren's satellite image of the Great Lakes, you see that interaction between the landscape, the waterscape, and the airscape. And so, we're seeing as water levels change, the direct impacts those have on our shorelines. But then you add, you compound it with, say, a coastal storm, and then it creates even more alterations potentially, or direct impacts to human activities on the shorelines as well. Being within NOAA's Office for Coastal Management, we look at coastal management as the actions that helps to keep our residents safe, the economy sound. We are, after all, in the Department of Commerce. And of course, the natural resources along our shorelines functioning. There's got to be that equal balance amongst all those efforts. And so, more importantly, too, we want to work towards the protection of our coastal communities. And so today I'm going to talk about, again, very briefly, the complexity of these water levels that we're seeing, how that relates to the physical impacts of the shoreline that we see, and then also touch on the economic and social impacts involved with these water level changes within the Lake Michigan basin. Next slide. So as Lauren showed, when we talk about water levels, especially in Lake Michigan here, you can see the amount of variability that has existed, since 1918. And again, this is data derived from the Army Corps of Engineers and the NOAA water level dashboard. And what you're seeing on this chart is, what that record high water level looks like, what the record low water level looks like. The black line in the middle is the calculated long-term average for water levels. And then the blue is actually that monthly average that Lauren discussed. And then the other thing we've plotted here as well is that 12-month average. What does it look like over time? And so, a couple of things stick out. The decade of dry more recently since 2000, as Lauren pointed out, that we experienced. And then again, that rapid high that has come up since 2013. And just how quickly that is compared to past water level changes. We say it caught people off guard, but it might also be the fact too that we've never seen as dramatic of a rise in water levels over a given period of time when we look at the historical record. The other thing is, when discussing coastal impacts and water levels, is trying to figure out, how do we adapt to or build to be resilient against water level changes. And so just taking into account that, during this time period, we've seen a difference of close to over 6 feet change in elevation. And so when you're talking about building a seawall, do you build it for 3 feet? Do you build it for 6 feet? Or again, how or far do you set your property back if you're building a structure? These are a lot of the things that we have to take into consideration. And of course, the golden question is, well, what's going to happen in the future? And so you could look at, something like this in regards to the water levels, and it's very faint, but there's a very thin lime green line in there. And that's just a linear trend line. And so some might argue that, hey, it looks like water levels are going up, but again, this is just one trend line using a very limited data set to try and figure out where things are headed in the future. And as we discuss climate change, and what that might bring, there's the additional potential trifecta, as you will, where we have high water levels, and then a coastal storm brings in rain that's contributing from the terrestrial side together with waves from the lake side. And it really has a direct impact to the shorelines along our coast. If we go to the next slide, quick. I mentioned, so what do we adapt to? What does it look like? And this is actually taking all the water level data for the Lake Michigan Huron Basin and just plotting it as a histogram. And so, you could say, do we build from 175.57 meters, which was the record low, to 177.5, which was the record high? And again, that's that 6 foot difference. Or do we look at something like, the 175.97 to the 176.93 and look at only maybe a meter of change? But what's interesting is no matter how you try to adapt to these ranges, you first have to agree upon what is that variability that we're going to experience. And as Lauren pointed out really well with the co-op station, it's not only the regional variability, but even the more local variability that you have to try and figure out how to adapt to. And so it's really important to look at this from multiple different scales moving forward. Next slide. So one of the easiest things that we can go out and look and see, and Lauren provided some great photos of the damage that we actually see, in regards to the high water level. So coastal flooding, shoreline erosion, and that sediment, as it erodes, it has to be transported, and it deposits elsewhere. And so there's the costs associated with understanding that. The increased sedimentation and transport, I'll show that here in a little bit, in the littoral zone and how that alters streams and river mouths, but also it alters our coastal, terrestrial, and wetland habitats as well. And then, as I mentioned, dealing with high water levels is one thing, but then having high water levels together with a coastal storm that may be right in your geography or on the other side of the lake itself can have a direct impact too on how coastal processes are carried out. Next slide. So one of the things, is to get a good sense of, what are the assets in the shoreline. And so in 2019, and actually just earlier this year, we released the 2019 U.S. Great Lakes Hardened Shorelines classification data set. And for Lake Michigan, here you can see a breakdown of what the shorelines look like. And so, as we would expect, the majority of the shorelines in Lake Michigan are associated with the beaches, whether those be fine or coarse sediment beaches. And when we say coarse sediment, that's things like boulders or cobbles. Whereas the fine sediments would be your sands or silts. The other big piece is the wetlands, but it's interesting, a majority of that is actually located in the northern half of the Lake Michigan Basin. But what's really amazing is 1/5 of Lake Michigan shoreline is artificial or man-made, or hardened is the other term too that I'll use interchangeably here. And so it's really interesting to see this breakdown of what the assets are out in Lake Michigan. Next slide. So as I go through these, it's really easy to summarize this and think about it as fifths. So right now, based off of the analysis we ran, 1/5 of Lake Michigan shoreline is classified as artificial or hardened. And again, this is coastal infrastructure such as jetties, breakwalls, protected shorelines, armored shorelines, and so forth. As part of that classification, we also went in and looked at the condition of those shorelines. And it's really staggering to see that, you've got about just a little less than 9% that's rated in poor quality or poor condition. Whereas you got about 60, a little over 60% is in that moderate quality. And then you've got the remainder in good quality or actually high quality. And so when we talk about quality, this has to do with, how many more years do we anticipate that structure to be held in place? And so as you can see, a majority of the armored shoreline or the hardening that's happening out there is considered moderate to poor. That's the majority of the shoreline. And so when you think about coastal infrastructure and where to focus on ensuring the protection of our coastal communities, it's staggering to see, that things are starting to slip behind a little bit in regards to that infrastructure. Next slide. So if we look at our natural shorelines, so again, thinking about beaches, for example, 2/5 of Lake Michigan shoreline is this fine or beach dominant. And again, about 72% of that is actually the sand dominant. So when we talk about water level changes, you can think about these being areas that can be mobilized as water levels start to rise. And so they're very high dynamic, they're susceptible to changes. And again, that can be either from a storm, the high water levels, and again, alterations to longshore or littoral drift as well. So thinking about how sand moves through these systems. Next slide. And lastly, wetlands. That makes up another 1/5 of Lake Michigan shorelines. And these are associated both with along the shoreline, but also the river mouths as well. And so it's interesting here, as I mentioned, you see the majority of these located in the northern part of Lake Michigan. And that's driven primarily both by the geological and geomorphic settings, but also too with anthropogenic. So again, thinking about the shoreline in Illinois and the built out environment associated with Chicago and the communities there, we start to see a decrease in the amount of wetlands present in these locations. Next slide. And so getting back to that discussion about littoral drift and sediment movement and the changes that we see, we've been working very closely with the Illinois the Illinois Coastal Management Program and the Illinois State Geological Survey to look at some of these direct impacts that we're seeing over a shorter amount of time. And so here's a comparison between 2008 and 2018 at Illinois Beach State Park. And what you're seeing are two locations where we've seen some dramatic erosion occurring. But then the question is too, where is that sediment moving to or from? And so on the far right, this is a comparison between 2018 and 2008 digital elevation models for the coastal nearshore environment. And so areas, again, that are highlighted in red show erosion, whereas blue is actually showing deposition that has occurred between these 2 years. So you can actually see where sediment from the north there being eroded out is transporting right now along the near shore. And again, that does have a downstream impact. The sediment can start to fill in our harbors and navigation channels, and there's an added cost to try and move those sediments out of those areas and back to these areas where they've eroded from. Next slide. And so while we tend to think a lot about the physical damage because that's easy to see, there is also more than that at play. And that includes our coastal economies and the social impacts associated with that as well. We can think about the damage to the coastal infrastructure and the cost it takes to repair or replace those. As Lauren mentioned, marinas having to close down because they're flooded out, and then the safety concerns in regards to underwater electrical boxes being underwater and so forth. There's the additional increase to hazards in navigation as things start to erode out from our shorelines. It might, pull out some large weight debris that poses a risk to recreational boaters, as well as our shipping industry as well. And then we see too the damage and loss to private property. And stress that causes for a homeowner to think, is this the storm that's going to pull my house down the bluff? And so we're also starting to think about this from the societal, the nostalgia or this distress caused by environmental change as well. Next slide. And so there are data and tools available to help understand these impacts. I mentioned the 2019 Great Lakes Hardened Shorelines classification data. That is a static data set providing a baseline of what the shorelines look like at this time. But there are other tools like the Lake Level Viewer, as Chiara mentioned, where we are helping people to visualize what those impacts look like. And so, based off of user input from a 2013 coastal storms workshop, a lot of people were saying that, we just didn't have the data or visualizations to help us understand future lake level changes. And that's why we created the Lake Level Viewers to meet some of these needs. Next slide. And we're not the only ones creating useful data and tools. The coastal programs, as well as the state agencies, have created some really useful tools for each of their states as well. On the left, you have, for example, the Wisconsin Shoreline Inventory, an oblique imagery viewer. This is actually, in this particular scene, showing the bluff erosion or condition susceptible to erosion. And on the right, you have the Great Lakes Shore Viewer from Michigan, again, capturing some of that similar information and showing those oblique photos to help people understand how the shorelines change over time as well. And these are just two examples. There are several other tools coming online from other partners in the Great Lakes to help people get a much more local understanding of how water levels change and alter their shorelines. Next slide. And last and foremost, being with NOAA's Office for Coastal Management, we work very closely with the other Great Lakes Coastal Zone Management programs. Each state has a Coastal Zone Management program. We look at this as kind of our support network. They're the ones working with the folks on the ground, and we're coordinating with them and helping them to provide the data, tools, and resources that they need to meet their needs and their constituents' needs as well. And so I highly encourage too, and I'm glad to see quite a few of our coastal program partners on the call today, because again, they are a valuable resource that we depend on quite extensively. Next slide. And with that, I just want to say thank you very much for giving me the opportunity to present today. Thanks.
Thanks, Brandon. We did receive one question so far, actually from the Illinois Coastal Management Program. So Vidya has asked, for what types of decisions do you expect states or regional planners to use this data set as is? Or for what types of analyses do you think we should enhance or localize the resolution of the shoreline type classification and hardened shore structure inventory?
That's a really good question, Vidya. And actually, we created this to fill a need that we heard through our Army Corps of Engineers partners. They developed a classification for Lake Ontario, and then we helped to scale it up across the Great Lakes Basin. And what the intent here is actually to serve as a baseline data set that hopefully, say in 5 years, we can go back and repeat and look at these changes over time. And then it kind of helps to highlight where those troublesome spots are. Where has coastal infrastructure failed? Where are we losing additional natural shoreline types? One of the ways that we're actually talking with some of our coastal programs and helping to enhance this is we did not attribute elevations to those coastal infrastructures. And of course, when we talk about these high water levels, some of the coastal programs are actually looking to add that information back in. So when water levels do exceed those shoreline protection structures, they're no longer doing what they were meant to do in terms of protecting the shoreline. They've been overtopped or compromised. And so that's the other thing too, is we're hoping to incorporate more of that three-dimensional information with these types of shorelines.
Okay, great, thanks.